Alrighty. Hello, football betting, machine learning friends, my literal friends who I try to give good picks on during the NFL season, but got wrecked last week. I'm recording this. I'm going to do a little bit of a review of last week's picks and how terrible they were, and then also go through how I get the data for the model that I'm doing. Feel free to ask questions in the comments. I might make better versions of these videos, and I want to make a better version of the spreadsheet, not just in its picks, but in how it's displayed. So I think when it's settled in a bit, I might do slower, more detailed videos. But yeah, let's look at last week. I think I didn't actually put in results for the Monday night game yet, so I don't remember the exact score. Let's look it up. 16-17. So 16 minus 17, -1. So the actual result. That's there's a couple quirks, and I point this out before. Like when I put the odds here, it's just kind of the spread. It's probably the inverse, like negative in front of what you see typically online. But I just programmed it that way 3 years ago and don't want to change it. Um, but anyway, so that's what this actual is. I'm subtracting the score of the away team and I'm subtracting the score of the home team. So I'm subtracting the home team score from the away team score. And that's how the model is making its picks, which I'll get into. I'll load the data for next week, for week 2 of the NFL, and then I'll run the picks and show you how that works. But these were the picks that I shared, and they were pretty terrible. These highlighted here are underdogs, like an upset it was predicting. And let's look at the results. So here keep track. When did I pick the winner? 44% of the time. So almost 50-50. But you notice that the odds picked the winner 55% of the time. So I didn't even do as good as the odd, the spread in picking the winner. And this is actually pretty bad for the spread. They usually do better too. Like a good week is the spread does 60 and I do 70%. So that was really bad. And then beating the spread, obviously, this is usually a 50-50 bet. So 30% of the time. And the bets that I made, it was even worse. I think some of the bets I doubled down on the stuff that we lost, and we don't bet every single game exactly to the what's predicted here. I talk with my brother who watches NFL sports all the time, and then we kind of come up with picks together. But the stuff that we decided to bet on, we lost more. I think we made like 10 bets and won 3. So. Yeah, here you go. Here's Jeremy's I put, these are the notes. These were the teams Jeremy liked last week. Let me see if Jeremy liked the Niners, and they lost to the Bears. I like the Niners too. Jeremy liked the Eagles. The Eagles, that was our one game. We got pretty well, but actually there was a garbage touchdown at the end of the game that the Eagles didn't beat the spread. So I bet the Eagles to beat the spread. Jeremy liked the Steelers. I didn't remember that, but the model liked the Bengals, so we didn't bet that one. Jeremy liked Kansas City. The model liked Arizona. So we didn't bet that one. And Jeremy liked the Broncos. They lost to the Seahawks. Jeremy liked the Ravens, and the Ravens did win against the Jets. But yeah, the other guys, and we bet on that and won. I was supposed to double my bet on that, and I forgot. So that's funny. Like one of the 3 bets we won, we should have made more money. Anyway. So this is kind of the results, and that's how you would read this if you ever see it before. There's the away team, the home team, and then I run 9 different runs, and then they get averaged together. And I also look at this game, the Cleveland Browns-Panthers game, where it's like it was really choppy in the simulations here, and it was predicting like within 1 point, it was within 2, the final score. But that was a close game, and so we stay away from games when it gets choppy like that. Yeah, let me show you. So one thing I do is I copy this data out into this tab I have here, which has all the historical picks I've ever run. This was from like the playoffs last year. So I'm going to paste my new picks into here because that way I can do historical analysis, if I ever need to, of like, how often did I pick the winner more than the odds? Let me see like if historically the whole model on my column, did I pick the winner 171 times and the odds picked the winner 166 times. So I'm a little bit better than the Vegas spread over the course of however many hundreds of games this is. Um, but let me look. I want to show you, like, uh, if people know, I said I bet pretty aggressively week one because the past 2 or 3 years, I forget how long I've been doing this. We the model always does really well the first couple weeks of the year, like picks 14 out of 16 games or something. Like I get off such a high where I'm like, oh, it's invulnerable, it's never wrong. So I was, it's usually pretty good at the beginning of the season, and I don't think it's invulnerable. It's the best model ever. It is any given Sunday. And again, the spread didn't do so well, but I did think there are some reasons in the way that the data gets crunched into this, which I'll go into later, that the model could be better at the beginning of the year. Or actually, my theory is that everyone else is worse at the beginning of the year. Like the model's a little more robotic, and the teams that were good last year are probably still going to be good this year. And, for sure there's off-season moves and things like that, but people probably overestimate that impact, or just don't have like a way to pick the winner. So maybe like the spread is off a little bit at the beginning of the year, and we do better against the spread because let me find last year. I guess I don't have these. I don't have the dates on here. That would be good. But let me see here. Hold on. I guess I could count. How do I show this? Maybe I can't really do this easily. So it would have been, let me see, 17 games, there's 18 weeks. Yeah, maybe I got to count. I would try to find like the beginning of last year. Or I guess as far back, was this the beginning of last year? Maybe this is it. Cowboys Buccaneers, was that the first game of? Let's look it up. I just want to show you. I don't know, or maybe my memory, I want to, re-jog my memory. I don't know. Of course, Google isn't working. Did I lose my internet access? What's up with this? Hello? I don't know why that didn't work. Okay. Tampa Bay defeating Dallas. So yeah, okay, Dallas versus Tampa Bay. So this was the beginning of last year, and I picked the winner 11 times out of, we only missed 1, 2, 3, 4, 5. So 11 wins and 5 losses. So it picked the winner 2/3 of the time that first week. Whereas the spread only picked the winner 7 times. So we did 4 games better than the spread at picking the winner. And we beat the spread 9 times and lost 1, 2, 3, 4, 5, 6, 7 times. So 1/9. So we did way better than 50%. In betting, way would be 100%, but like in getting like a 10 or 20% edge against the spread is really good for sports betting. So we killed it. And the year before and the year before that, it was the same story where like the model just does super well the first couple of years, weeks of the year. And then it slowly gets kind of worse. Like it makes a little bit worse decisions. And I'm not usually tweaking too much about the model. It's just the data. Like one piece of what the model does, and I'll show that, is as new stats come in for the new year, I slowly blend those stats into, the decision, the machine learning model in TensorFlow that predicts the winners. So as new stats come in, you would think it would get better because it's more accurate about the current year. But in reality, like the model gets, guesses a little bit worse towards the end of the year. And maybe we could find ways to make it better. But again, I don't really think the model gets worse. I think everyone else gets better. And it's just harder to find an edge. And it's maybe like a little sloppier these first couple. It was sloppy last week. It's sloppier the first couple of weeks. So anyway, I'm rambling. Let me show you what I do. It's already Thursday. I got to get this in before the game tonight. I usually try to do this on Tuesday. So I take my picks. I make sure I put, the outcome. I see how it did. Let me get rid of this. I copy it into the all picks, so I have it kind of historical reference. I didn't do that always. I started doing it last year. So we also try to predict over and under scores. So I try to put, I put the results here. It was 16-17. And then, and actually, I should look at these results. So, what was interesting is I think I did this later in the first year I started using the TensorFlow model, or maybe the next year. I said, hey, let's just take the same model that predicts margin of victory and just have it predict only the home team score and then only the away team score. And then I put those together and I make an over-under bet. So for these, I do 3 runs of each, the away and the home team, and it makes a guess at how many points the team's going to score. And then it says, hey, based on that, who's going to win? And then it also, now I wonder if like the winners, I don't keep track of who won. But I think it usually makes the same bets on who would win. And I'm just kind of eyeballing it. And I don't think it was off on any of it. These are the way we bet. Yeah, and it liked the Patriots over the Dolphins for some reason. And you find over time there's teams that it likes the Cowboys. Here it picked Tampa Bay over Dallas. I think the model on this picked the Dallas Cowboys. And you see it was a little choppy. So that's kind of interesting that like when I ran it just for individual scores instead of the margin of victory, it picked Tampa Bay. But again, it was predicting a close game, 21-23. So anyway, so of course, like add up the scores and you get the total. This is what the model thinks the total score should be. And this is what the over-under was, at least when I put the numbers in. Usually around, Tuesday or Thursday the week before, I'll put them in. I often am only making the bets like over the weekend for the later games, and the spread or the over-under might have moved. But we look at like the difference, and then it makes a bet. Now, here's the funny thing about the over-under. I started sharing this, and you've been looking at it for a while, but I got to. The over-under pick here is terrible. It loses 60% of the time. So actually, I need to get these scores and put them in the all scores sheet. So again, this is similar to the all picks. It's just like, hey, the over-under picks for the whole time. I don't have a good way to add these up really easily, but you just kind of believe me on this, that it's like almost perfectly 60% of the time it loses, which is bad, right? But whenever you have like a prediction, like you make fun of with your friends, like you're always wrong, I should bet against you. This model is 60% of the time wrong, just bet against it. So last year, one of the best bets we made of the stuff coming out of the model was to bet against the over-under bet. And I actually didn't bet this the first week. I wanted to bet hard, and I was like, I'm either going to bet the over-under or I'm going to bet the picks. And I didn't bet the over-unders. I bet the picks. I should have bet the over-unders because you see here it won the bet 0.37% of the time. And actually, like, if I bet this model, I would have bet against it. So we would have inverted that. We would have won 6 out of 10, picks that we would have picked with this, or it would have been, 1, 2, 3, 4, 5, 6 games lost, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 games won. So if you imagine you were betting $100 on each of those games, you would have bet $1,600 worth. You would have lost 6 of those and got no money back. But for 10 of them, you would have doubled your money. So you would have made $2,000, $400 more than you put in, minus the edge that the casino or the sportsbook gets, which is pretty sizable. The online sportsbooks get like 5 to 10%, which is huge. And like this model has about a 10% edge. It almost all goes to the sportsbook, but we're still just having fun. So anyway, that's the over-under model. And it's funny, like the way I set it up, it's wrong. And so I just invert the picks. And I want to make a view of this that kind of like takes that into account, so it's less confusing for folks. The other thing though is if the machine learning model is consistently with this extra step of putting the 2 scores together, adding them up, and then comparing to the over-under, like consistently wrong, I should be able to like design my TensorFlow model so that it has like an extra layer to do that step. And the model itself should figure out like, oh, I should just invert my pick every time. But I'm actually not that good of a machine learning programmer to like be able to figure out how to do that. So if you are like, you're like, Jason, this is silly. Like you're doing machine learning in a spreadsheet. What the fuck? I want someone who's like really an expert on this to reach out to me and work with me. And I'm willing to spend some money to make a better system. But anyway, that's the results from last week. The over under did the same as it always does. It's like it's kind of crazy how consistent it is. And the what's interesting to look at too is like the difference. So was it more or less accurate the further away it was? And so this one it lost, but you see the difference was like really high. So it's a little bit better. I used to have a chart in here showing like how the performance of this prediction performs depending on how far away the prediction is from the over under. And it was the further away it was, the less predictive it was. So if you kind of exclude, actually, no, I think it was the opposite. Yeah, no, it was the opposite. So the bigger of a swing of a prediction it made, the like more often it was accurate. But so sometimes you can look at these and like throw some of these out. But this one, it really thought it was going to be a high scoring game, but that one it lost. And just it, you know, I don't know. So that it was interesting to see if we won or lost this one. This one it lost. I mean, it won, but we always bet against it, so it actually lost. I think it's one. Okay, so that's the model. I'll try to plug a chapter in here so we can skip ahead to this. This is the part where I'm going to show you how do I get data into this thing and then actually like run the model again for a new week. So I actually have two spreadsheets, and these are in Google Sheets. So this is the one that like performs the picks and where I keep track of the bets I made. There's another one that's just NFL data. And if we look at the bottom here, there's data going back to like 2018, but I kind of, the tabs I use are the 2022, the current year's numbers. And actually these numbers are the numbers for last year, because the first game of the season, I don't have new numbers. So I just mirror the old numbers. And which is like, if you hear me make predictions on the model, I'll be like, hey, the model, whatever, it picked the Seahawks, but it thinks Russell Wilson still plays for the Seahawks. You know, it kind of doesn't understand that it's a different team. It thinks that, you know, it's looking at past data. That's all it can do. So, yeah. Let me see here. I'm going to need more water. I'm going to lose my voice. So yeah, this is the data that it's using. It's using turnover data, every team, how many games there were. So you can divide by this to get like, you know, I guess this is, I don't even know what diff stands for here. Takeaways, interceptions, fumbles. This might be differential. Like how many more turnovers does it have than the other team? Total turnovers. How many interceptions? How many fumbles? Giveaways. So then these are the giveaways. These are the takeaways. These are the giveaways. Okay. And the differential. So yeah, if I had 34 more than 20, that's 14 difference. Yep. And so this comes probably redundant for the model, but that's okay. It's like not bad to have redundant data in the model. Anyway, so that's the team, the takeovers. We also have like the defensive stats, which is like, you know, how many rushing yards did they give up? How many passing yards did they give up? Offensive stats. And then this sheet called inputs kind of puts everything all together into one column. And then, the games I don't have, because actually this is the site where I get a lot of these stats, is footballdb.com. And if you go to game box scores, while I grab water. Internet's slow. The kids are home playing games. Okay. This is this website I use to get a lot of this data, and they have this really neat view of box scores, but for some reason they didn't have the 2022 games until just now. And so I kind of manually put in I like that I can copy and paste these now. I had manually put in all these last week, and that was really super annoying. One thing you have to do though is like double check these, because especially later in the year, they will rearrange the games. Okay, so man, there's two overtimes. I sometimes would make an overtime bet, and I wonder We could look at that. If the model's predicting like a game within 1 point, I sometimes will make an overtime bet. Overtime bets are often paying like 10-1. So let me see if I would have caught that. Colts and Texans. No, I think it was picking that. Yeah, 11-point margin. No, I really like the Colts. And then what was the other one? The Bengals Steelers. No, I think it was picking, margins of like 9 or 10. It did pick one close game. I said like the Seahawks Broncos game. I was picking within 1 point. So and actually that one was within 1 point. But that's one of the games that picked the winner. But we didn't bet that one because it was such a choppy, close game, and there was kind of I'm glad we would have got a push, I guess, or something, if we bet on the spread. So anyway, okay, so here's the data, and so what I'll do is I need to update this data. So I go to this NFL, the footballdb.com, and I'll go stats, team offense. And copy all this. So here's the offense. And then let's get the defense. And copy it. And the turnovers. Now there's one piece of data that I don't get, which is I don't get this, which is oddly enough, I don't get the scores of the games, and I don't get like who won the game. And I think in hindsight I would add that data. It's a little problematic because what you kind of want you want the model to be able to like predict the score, and if in your training data, I guess for training purposes, I would have the score to check it and definitely the margin to check. But it's kind of like that data is so strong. Like, okay, like the team that's 16-0 versus a team that's 0-16, it's like, oh yeah, the team with the better record is going to win. And in hindsight, I think the way the machine learning and TensorFlow works, it would be able to handle that. But at the time, I thought like, oh, that's like too strong a signal, and I'm already getting that signal. Like you kind of make those assumptions when you look at the games yourself. But I think it's like in reality with machine learning, it's like whatever data you have for the whole training set, throw it in there. Let the model figure it out, So I don't do that. And I guess another interesting point on that is there's a bunch of academic papers that I saw that say like machine learning can't predict an NFL game, like, with any kind of, better than random average. And one of the papers I looked at, like the only data they put in was like the records of the teams and the scores of the previous games, which is kind of like the most naive thing you could do. And it was like, oh, like machine learning is no better than like simple, formulas based on, the inputs of which team has a better record. And it was like linear distributions against, like the team records did just as good as machine learning in that case. But I was like, there's so much more data. Like the whole point of machine learning is like it can tell the difference between like, like a team with good passing. The other bit of data I put is like time zone, moving between time zones. I put the QBR for the NFL, for the quarterbacks in there. And it's like, oh, like a good passing defense against a good passing offense, like the machine learning model can figure out a little bit better than a human, I think, how that compares to like, will their running be able to make up for it since there's passing? Like it's like the model's finding like these weird connections. So the more data you put at it, the better it's doing that than humans. And so it's weird that anyway, these people got hung up. They're like, I gave it 5 numbers and it couldn't do any better. And it's kind of like, you got to give it everything. I say this, but like supposedly the NFL has a database that like DraftKings and other like ESPN, other people use that has literally like every single play since like 1985 or something like that. And that would be amazing to have a database, like a structured database of like every single play at every single point in the game, every single quarter. You could really stretch this out because you'll see like all the inputs when they get put together. I'm getting lost where I was. So did I get turnovers? So I got turnovers. And let me paste them in here. Okay, cool. Yeah, when in college, I had a buddy who made a model like this, and it had like some of these stats, but I think it was like maybe 10 stats per team, and then it took like 4 hours to compute the model. Like to pick it did something similar. It wasn't TensorFlow wasn't around. It was like an even more naive evolutionary algorithm thing. But it picked the winner, and it took like a few hours to run on 20 parameters. And when I looked up like current state of the art machine learning tools like TensorFlow, I was like, how many parameters can you really put into it before like you start straightening the system? And I was like, can it do 20? Can it do like 100 or a couple hundred? And it's like, oh, like it starts to slow down at 1,000,000 parameters. And I'm like, oh, okay, never mind. Like I'm never gonna, so like 1,000,000 individual stats about a team, will slow it down a little bit more than what I'm doing, but it's like within the realm of what, these machine learning algorithms are doing these days. Anyway, okay, so I put that data in. The time zones are always the same. The QBRs, this is actually one of the most time intensive parts, and this will be a big update, but I'm going to skip over it for now. But basically what I do is I'll go to, ESPN QBR, and they'll have the leaders. Now, what gets confusing is as quarterbacks start dropping out, like, I don't know, when the Steelers bench Mitch Trubisky, he's going to fall off this list. Excuse me. So he has a 48 QBR now, but when they start a different quarterback, maybe Mitch Trubisky's, is still on, actually maybe not fall off the list. He's still on the list at 18, but the other quarterbacks that are actually playing aren't on this list. But anyway, I can get the top 32, and then the starting quarterbacks that I don't get, I have to look them up individually. But basically, copy the QBR from over here. And that's the reason you can't just copy this and paste it, because this top list isn't necessarily the starters. But we want this season. I guess you could look at the weekly leaders. This might be new. Ooh, maybe the weekly leaders. But I think this gives you their QBR for the week. But what I really want to get is their average QBR for the season, which is some indication of like which quarterback is better than another, basically. Already the model has like passing yards, passing touchdowns and things like that. But it doesn't have, QBR will make it, when I add and remove QBR, it does move the model like 2 to 3 points. Where's Mitch? Plays for the Steelers now. So Mitch Trubisky coming into the season had a 73.2 QBR, and now he has a 48. So for next week, this is going to be a little smarter. Anyway, okay, so then what I do is I go, let me double check this. I need to update this guy. So because it's a new season, this is still pulling stats from the 2021 offense. So I need all these to pull stats from the 2022. And so actually, this is a little annoying. I do this once at the beginning of the year to kind of update this. And a lot of these things is like, man, if I spend time, I can make this a little smarter and a little more, easier to maintain. In reality, what I want to do is take for sure all the machine learning aspects out of Google spreadsheets and, maybe just generate some of the, okay, the QBRs is on there. Okay, cool. Okay, and I need to pull these down. All right, cool. Oh, Washington. This is like one of the things that happens is the teams that are changing their name, like it causes issues in like all the lookups. So okay, so I kind of have to, everywhere else it's still called Washington football team. So I think the easiest, I have to update a bunch of other spots to handle Washington Commanders. Is that what they're called now? But I think the quicker fix is for me to just update these for now. because there's a bunch of other spots in other sheets that's still looking. It's really so silly, right? They haven't won Las Vegas. The Raiders moved. Okay, so here's my inputs. It's really getting the current values, and it's not missing anything. Okay, I don't have to copy and paste this. This is just available. What happens next is I go to this matchup tab. So this is kind of like where the magic happens. I forget like which of these columns it looks up. I think this one, but for some reason I have it here too. But basically what I got to do is go to this week's games. This is how I like loaded up the data. So I'm basically building the data set that's going to go into the machine learning system. So I take the teams, the the away team and the home team, list them here. And then I have a little script here I run. So I'm going to go extensions, app scripts. And what it does is it goes through the games, loads them up here, and then this pulls in their 2021 average stats for the whole year for each team. And then this pulls in their 2022 stats for, what the heck is this guy? It's really weird. Oh, how many is it? Like what game it is? Huh. I should look at how that's kind of weird, out of place. I forget how that one is. But yeah, okay, so what it's doing is we'll see how it works, and maybe I'll fix this and post different reasons. It's always like weird at the beginning of the year because I have to like reconfigure this. Yeah, so it's like, hey, it's going to get the new stats and the old stats, and then it blends them together to like make an estimate of like, well, how good is this team really at passing? And what the formula I came up with, and in reality, what would be great would put this whole system in a black box and then tweak this aspect of it and see like how the model performs. This could be another reason like why it gets dumber throughout the year. But basically, I weight as the year develops, I weight last year's numbers less. So at the beginning of the year, I only have last year's number. And then after week one, it's as if like I have, I take the first week's numbers and then that's like, and that's 1/15 or 1/16 of like, the stats that go into it. And the other 15/16 is last week's numbers or last year's numbers. It's a little, I forget the exact formula, but it's a formula like that. So like over the course of the season, it's going to use the current season's stats more often than the last season's stats. If that makes sense. So I'm going to run a script, and for this script to run, I have to choose like the teams. This is a pretty simple one. So I'm like loading the data training, and it would take me a while to go through, but it's basically going to do what I just hand wave through. So I click run. It's gathering all the stats. You can kind of see it working. Shoot, I wonder if I have see, I'm getting NAs for the Washington game again. I feel like it kind of goofed up. So if you put like, you can manually do this too, to like see how it should detect that. Oh no, it's actually looking up here. So anyway, why did it get the command? Oh, because I copied the games and it says commander. So I have to, again, call it a Washington football team. Okay, so if I just highlight this one, it'll do it just for that game. Hold on. I got to do them all again. This part of the script runs fairly fast. So, and you'll see it's kind of swapping them in, getting the stats, combining them, and then copying them down here. So now I have the data to load. I have the games. Let's load it. So I go into this other spreadsheet. So this one's called the model with picks. I go to the data tab, which we haven't seen yet. And this is like all the data with dates, I think. Oh, these old dates are funny. Like Excel does this where like it takes your date and converts it to a fucking number. But you can see, the dates of the games. So then what I do is I can maybe move this stuff down. Hold on. Yeah, let me move this down so I have that. And then It's funny, like this sheet, this is another thing that could kind of be improved, is like put some of this output stuff on a different sheet so I don't have to always move around. But anyway, I get the teams, I load them up here. Let me get the dates too. Okay, cool. So these are the games. Let me put a line in here. And then I'm going to get the data. So in the matchup tab, I have the data here. And this again, like points per game, yards per game, interceptions per game, all that stuff. This last year, it's always a 0 on the last column because it's how many time zones did you travel for the game is like one of the columns. And so the home team traveled always 0, right? So anyway, take that data, go over here, paste that in here. Click the button by accident. Did I paste this correctly? Paste that in here. Okay, cool. So now I have, this is the data that goes in. Let me show you how this works. Now what I do is I'll select the games. I could put the results from last week's game in here. Yeah, and then it'll add to the training data, so then it can train on last week's games as well. So hold on, let me get the scores from last week's games. I kind of eyeball, like, you want to double check, is the order of the games the same as how I put it in? And actually it might not be because I had to put these in by hand last week. So actually let me paste the teams in and see if they're in, of course it says Commanders. But okay, I had the games in the same order. Okay. So I'm putting the right scores. And then, this is just a equation. What's the margin? And then this is actually, I forget what formula this is. It's like, the predicted, what did we predict? So did we win or not? This total column, I use this column for a couple of things. And right now it's just saying, did we pick correctly? For different, depending on the model, like the function that I run, it dumps output into the spreadsheet in different columns of like the predicted total, the total for the game, over and under. But I'll show you how it works for what I'm doing. So anyway, I select, these are the new games. I'm going to select them. And now I go into the script here. And this is like the brains, basically. This is based on this guy, Ivan Qteal. I may not be saying his last name correctly, but he 3 years ago posted the blog post of like, hey, I put TensorFlow into a JavaScript in a Google Sheet and it kind of worked. And that's what I did. So this is and this TensorFlow has been updated over time, but this is the version of like Google Scripts TensorFlow that I copied a few years ago. In the way that TensorFlow has been updated, I don't know that just using newer TensorFlow would make the model better. It kind of like has it's really how you program TensorFlow that, makes it better or not. And there's maybe features I could use if I had a newer version. But anyway, it's funny. It's like it's weird. And I forget how big this is. If it's like a gig, it's like crazy. I mean, I don't know. It's like a really big JavaScript file. There's some constants here, which is basically like pointers to like where things are in the columns. The row splits the training data and the test data. So part of TensorFlow modeling is it trains on some data and then it tries out, on another half of the data to see how it's been doing. And actually this is a room for improvement because it basically trains on like the oldest data and then tests on more recent data. And I think it works that way. It could be like a smarter thing to do is to like randomize the data. So some of the training data is recent, some of it's old. And randomize it, some that's tested is old and new. What's interesting about football is some of these numbers of like the batch size, how many games you're kind of looking at once, the machine learning model, there's some natural numbers of like, there's about 16 games per week, so numbers that are close to, multiples of 16 are going to be like a whole week's data. And I don't know, like, how much is every game an independent game, or are there kind of like weeks where, like the batch size matters in a sense that like taking like this week was crazy, and like I don't know, there was lots of upsets because chaos in the football league, or towards the end of the season, like teams are playing differently for the playoffs and stuff like that. So if your batch size is kind of roughly equal to a week, the model gets like an idea of like how late in the season it is. Anyway, let me look at the data. We have 1,079 columns of games with outcomes. So about half of that would be, 530 or so. So, I mean, splitting at 650, it's actually like a little, I don't know, that's okay. It has more training data than test data. And then the output row is like, it's going to dump some numbers. I have to always move this down like, hey, like let's move it to 1100 so that it dumps out at the bottom. How many trials? It kind of operates differently if I'm doing 1 or 3 trials at a time. It basically runs the data 3 times in a row. I probably should run it and then walk through it takes like a couple fucking minutes to run. Okay. So let me, MOV, there's a few different functions like total scores, away scores, home scores, the win-loss, some of the, like the win-loss I never got to work. Team stats is something I'll talk about at a later date. But anyway, the MOV is the main one. Let me run it. So I selected my games and I said run. And it's going to execute, and I'll keep talking while it's executing. This is a longer video than I thought it would be. All right, these are some inputs that might be familiar for people doing TensorFlow and machine learning, like the learning rate, which is kind of, to like a layperson, like, is kind of like how big of a jump does it make? Oh, I guess, I mean, I don't know. How does this thing even work? What is it doing? It's basically trying to build a neural net, which is this like black box computer that can guess the outcome of a football game based on all the data that we put into it. And the first time it runs, it's random and it's terrible. Like it just makes random guesses basically. But then what the system does is it like corrects itself. It's like, well, was it really random or how'd you do? And it slowly tweaks some of the weights in this neural net, some of the ways that it figures out. It's like, oh, maybe rushing defense isn't that important. Maybe passing defense is more important. Maybe QBR is more important, like the importance factor of all these inputs. And it's like, okay, guess like that. And it gets a little better, a little better, a little better. And actually, so this thing called train loss is in reality, how many points is it off in its guess of like over a batch of, it doesn't sound right, 90 games? Maybe it's less. Over a batch of 90 games, no, it has to be more than that. It's like 30 games. Like what's the difference in my guess, the model's guess at points, and then the real margin of victory? So, and actually, I mean, 211's, maybe it is 90 batch because it guesses in both directions. But anyway, it's like, hey, how far off am I on my guesses? And this number gets lower and lower over time. So if the model's getting better, this number's getting lower. And then you see the jump up is because it's running three times. It builds a model, and then it spits it out, and then it tries again and tries again. And I do that so it builds 3 different models, and I get kind of, the inputs into the models are the same, but like when you train it, it comes out a little different. So at the end, it's like the training set loss, and this validation and test set loss are always higher than the training set, which is again is like these folks who know machine learning better than me would kind of like optimize this to get better guesses. What I tend to do is run the model and then run it historically on all the data and like see how it did and calculate wins losses basically. Like, hey, if I took the model and I basically do another test. If I took the model and I tested on every single football game I have in my database, like how often is it guessing right? And then that's how I decide kind of like which models to use for the week. But anyway, like when it trains, there's this thing called, let me see, am I done? Not yet. There's a thing called overfitting, which is basically like, okay, so you can imagine the model is a black box computer. It kind of has memory. And so what it could do is it could just learn, if the date is September 9th and Tampa Bay is playing, I wish I'd pick I forget the games, who they played last week. Tampa Bay is playing, who the fuck did they play last week? Um, this is dumb. Why don't I? Where are they? Oh, the Cowboys. Okay, so yeah, like if it's in September and Tampa Bay's playing the Cowboys, Tampa Bay's going to win. If it's what I mean, like it learns just the history, and then you just give it a guess, and it kind of get it sucks on novel that what we wanted to do is predict next week's games that haven't happened yet. So it predicts perfectly every game that ever happened because it just memorized it. So that's called overfitting, when your model just like memorized the outcome, which can happen if you make your model kind of too big, too good, too many inputs. Like historical NFL games, like hundreds of games, it's kind of hard, but it just would memorize like these games look exactly the same. But that's also to say anyway that the training set, it's always going to be better on the training set. That's what it's training on. And then the real test is like, okay, these other games now try to predict in the test set. How did you do? And it's always like a little worse, like twice as, I mean, in my model, I keep track of a little bit, but like twice is pretty bad. But it should be like a little better than it, ideally, like a little better than twice as good. Like less than twice means that it, let me see. Did I get output yet? No. It's still running. So if I scroll down here, it's doing the third test. Oh, some of these inputs. So the learning rate is basically like how much does it randomize between tests to, how fast is it going to learn? And if your learning rate is really high, it's kind of wild, and it'll do really good sometimes, but it's kind of like prone to overfitting. But if it's too low, it kind of will meet what's called like local maximas. It kind of will like get into a rut and be like, this is pretty good, and it won't, change enough to like really, figure out the problem. So you tweak this, and you kind of like different values are going to end up with different results. So batch size is how many games it does in one batch. So it kind of predicts the games, it tweaks them, predicts them. And then epochs is how many times does it run. So, and that's why this has actually taken a while. I usually do like 150 or 200 epochs. It's doing 350 because I think last week when I was training it, like it kept getting better. And so it was like, oh, as long as it's getting better, might as well keep running. And we'll see. So 350. And then the layer size is how many nodes are there in the neural net, or how many parameters, like how big is the memory space that the model takes into account. And a bigger layer size means it's going to take longer, but it potentially is going to be able to understand more complicated things, but also potentially could overfit. And then there's lots of code in here, but the two that kind of matter that I tweak these are the layers that are like doing the work. This is a bunch of weird coding, but these are basically like, this is the input layer. And then it's like, this is the space that the neural net has to kind of like figure things out. There's two layers of 120 different nodes, and it basically figures out weights for those. And that's what's getting, I mean, I don't know, this is the point where if I'm editing, I would insert some kind of like YouTube video of like how machine learning works in general. I'm using like a mean squared loss algorithm. That's kind of important to certain people. And then, I don't know, this is the code. It kind of loads it up, loops through it. And then, boom, it spits out 3 different runs where it's predicting the margin of victory in these games. It puts the last run here. So I kind of get the spot check, like the last run. I'm kind of out of time. So basically, let me just take, what I got to do then is update my picks tab for the new teams. This is another thing. It'd be cool if it kind of did it automatically. Let me clear out the data. Let me clear out the odds and the actual. And this is kind of like, I kept track of like how the odds shifted, so I added a column there. This is kind of like how it starts. So let me get the results. And I go here, and it's like, boom, here's the picks. It takes all these runs and then averages them into a margin of victory, and then it tells you like who it thinks is going to win. Here's the prediction of the margin of victory. It doesn't know, in this way I ran it, it doesn't know the scores of the home team and the away team. It just knows like the difference in score. So it thinks the Buccaneers are going to beat the shit out of the Saints. The Broncos are supposed to beat the crap out of the Texans. Some of these games are choppier. The Niners-Seahawks game are going to be close. And then some of these stats, these are those inputs I talked about, like the batch size, how many epochs, and the layer size. And then this is the training set loss. Lower is better for all these. So this one was lower, but you'll see like the test set for this middle one. This middle one was probably like the best run, because like a lower number on the test set means that the model did a better job predicting games it wasn't trained on, which is kind of the definition of what we wanted to do. And I could kind of like compare, this is something I could actually do better of, is like keeping track of this. And actually, ideally, what I should do is like build a model and just keep it and reuse it week to week without retraining it all the time. But the way the spreadsheet set up is not like that. There's different people. Some people like retrain their model like in real time all the time. Some people like, hey, I got a model that works. It's pretty good at guessing football games. I'll just keep using it. In reality, like we're getting new data. Like, you know, a model that predicts last year's games is going to be as good as a model that predicts this year's games if like you give it this year's data potentially. I don't know. So anyway, that's how it works. And now I have some picks. And then yeah, this confidence score is basically. It's going to be nothing here, because what I got to do is look through DraftKings and get the odds for each game, the spread, and plug it in here. So if the spread in the Chiefs-Chargers game was, you know, -5, like it thinks that, you know, the spread is that the Chiefs, you know, should win by 5 points, and we predict they win by 5 points, like it's like, yeah, I'm pretty much in line with the spread. Whereas, you know, it could be wildly off. If it only thinks if the spread is only 3 for Tampa, but we think Tampa's going to win by 17, it's like, whoa, we're making a guess that's far away from the spread. And that just kind of shows me what to focus on, like what's the model doing. So here's like the preliminary picks of like, the Chiefs are going to win by 5. This is how you read it. Like, how much are the Chiefs are going to win by 5. The Tampa Bay is going to win by 17. Panthers are going to win by 6. And then I'll do it quickly, and I'll end this video, but basically let me show you what I do to do the over-under. Is if I go back to this data tab, I select the games, I go into my script, and I say predict away scores. And I say run again. And it's going to use these inputs. It's going to take forever, so I won't even keep it on camera. It's going to run the same thing, but what it spits out instead of being the margin, it's going to be the away team score for every one of those games, 3 different runs. And then I usually take that and put it into the scores. And maybe one of the reasons the scores does better is like I just kind of was like lazy here, where you see for the picks, I do 9 different runs, 3 sets of 3 with different kind of inputs to the training. For the scores, I pick whichever one seems best and just run that. Whichever input seemed to pick like a really good margin of victory for that week, I just take those same inputs, run it, and then dump it for the scores. You know, so 3 away scores and 3 home scores. And they're usually like a little more homogeneous, the results here, because it's this not the same exact model, but the same inputs into a model making guesses. Whereas like it's more scattered if you're changing your inputs. So anyway, that might be confusing to some of y'all folks, but if it's just interesting to you, that's how I get data from footballdb.com, plug it into my data spreadsheet, massage it a little bit to get, you know, data from last year and this year. Then I take that data, I put it into this spreadsheet I have that, you know, has the results from the past few years' games. I use TensorFlow in a Google Sheet then to train a model that predicts the games, and then I put the outputs of that models on this week's games, and I put them into my pick sheet, which kind of averages them together. You put the odds in, and it's one more data set. So I'll try to like make more videos if people are interested, or dig out some of the stats. I can look at like some of those all-time picks. In the past, the model, like I said, the model has always done amazing, like the first couple weeks of the year. And so I doubled down on my bets, but this year it did terrible, and everyone did. I think like when 1 week last year we like lost almost every bet, and like there was like headlines of like Vegas loses the most money on sports gambling. Not Vegas. Vegas had their best week on sports gambling ever, because everyone else betting, lost, because there were so many crazy upsets. And that's actually something that I'll try to rehash with my brother, is kind of like, okay, the model was wrong, but was the model wrong, or was like everyone wrong? And then looking at this week's stats, like, okay, the model learned a little bit because it did train on last week's game. It was like one of the hundreds of games it considered. But like it won't move that fast. It's still kind of, pretty similar to how I was thinking last week. Is the, and is that a good or a bad thing? Like, are there lessons the model should have kind of learned about, which teams are good or bad this year? And of course, it's funny. It's a middle ground. Like my brother, who's watching sports all the time, will tell you like, oh yeah, like this wide receiver, he's all washed up. He'll never be good. This guy got hurt, which actually is a real thing. Like, of course, like the running back got hurt, and the backup isn't good. But a lot of times the backup is, just as good or almost as good. And actually, it's a good offensive line is why they were running well. So I kind of get the NFL football news from my brother, and kind of the model is dumb. Like, I'm just looking at the numbers, and I kind of don't understand, the players. Which incorporating fantasy stats, if you can grab it for a bunch of years and build like a spreadsheet that puts them all into the team for who's starting, that would kind of be more data that would make this smarter. It really would. I wouldn't say that anymore where it's like, it doesn't know Russell Wilson is quarterback. It's like, oh no, it does. Like, it knows Russell Wilson, and it has a set of like 20 stats related to Russell Wilson that it's going to take into account instead of just one. And actually, I'm going to go back and update the QBR before I build this out. But anyway, that's how I get the model. It usually does pretty good. It usually picks the winner like more than average, a little bit better than the odds. And it usually like beats the spread, but not enough to beat the VIG of like DraftKings. However, in the over-under bets, it usually consistently loses, so you can bet against it. In the past 3 years, it's done that better than, then it seems average. And if there's like I forget it, like it's very unlikely that it's random, like over that time, like shoot, I don't know why I'm dropping on like the P-score of like why, did it randomly get lucky over the past 3 years, predicting over under? It's very unlikely. It's like, 1 in a million that it's random. It really has some kind of edge potentially. And that's why I wish like a machine learning person that could like help me understand like, some of it's black box, but like, what is its edge? Or could you like distill it? Because you like, what is it actually doing? Is it just betting over more often, and like over is more, I don't know. But it seems to have an edge in the over under bets if you bet against it. Almost like a little bit more than 10%, which means like if you're paying 5% on the bet, you still make 5% on every bet that you make. And I don't use this for money. I use it for, I do bet real money with this, but it's for fun. And I think it is useful whether it's, really good at picking the winner or kind of good. What this does is like, it gives you a very literal, this is what a dumb machine thinks the outcome of the game would be, which is good input. Like, it's a good head check. Like, if you think who's going to win these games, it's like, well, you should maybe, if you think, Tampa Bay is not actually going to beat the Saints. That's a bad example. The Tampa Bay is going to crush them. Here's one like, yeah, what's an actual like competitive game? Titans versus the Bills. That's interesting. Okay, so you're like, oh, the Bills played so great week 1. They're going to crush the Titans. And you're like, well, for some reason, the model still thinks it's going to be a little closer. It's actually, what's the spread on the Buffalo game? I wonder if 9.5 favorite. So yeah, the spread is 9.5 favorite, but this is only predicting, a 4-point favorite. So it's kind of like, it gives you that data of like, ooh, why is that? Is the model dumb, or is the model know something I don't know? Is the model not overreacting about news around these two teams, or being, selective memory of recency bias of Buffalo Buffalo's a good team. They're a contender this year for sure, and even last year. But the Titans are a good team too. So it's kind of like, anyway. I'm gonna keep pushing out these picks. If people are interested, let me know. Thanks. See ya.